Hi, I'm Kenneth Rexer here at Stevens Institute of Technology, and I'd like to talk about some of the research I've been doing in the math department with Professor Jan Cannizzo. So the reason I like doing research, and I've been doing some research with him regularly, is that I want to be a professor in the future, and this is great practice for then. The research problem we're trying to figure out is involving graph theory, and what we do is, here's the problem. First take a graph which is a cycle of length n. Here n is 6, it goes from 0 to 5, and then you'll take another graph which is exactly the same. What you do is you create a map from this first graph to the second where you glue this vertex 0 to 3 and so on. So it'll be 1 to 4 and 2 to 1 throughout this random permutation of the second graph. And then this is the result here. And as you can see, it's a regular 4 graph where every vertex has exactly 4 edges. What we're trying to look for is, can we find a cycle of length k? So for example, is there a cycle of length 3 in this newly created graph? And this problem gets interesting as n increases. Can we get a probability function for n where we even calculate as n tends to infinity, what's the probability of a cycle of length 3 or k? To do this, I wrote up a Python script which will generate these graphs. So for example, here is one of the graphs, and as you can see, every vertex has degree 4. And what we do is we create every possible permutation for each value of n. So here n is 4, and we export every cycle length that exists for n equals 4. Then we would increase n and so on. And this gives us a look at the proportion of cycles within the graph of a certain length. And as you can see, the proportion of small cycles is disappearing as n increases.